Hello students, we are going to look at Hooke's law right now. I would like to direct you to your folder on Dropbox, and so it's 17, and I'm just going to go to the template here that I provided for you guys. And in the template, you'll see that I have something dealing with the first compression length here, and then I have the second compression length and the third compression length. We actually need to acquire the data for each one of these, okay? For the first click, the second click, and the third click. Now, what's beautiful is we've already acquired this data, okay? And we did it in the last experiment when we were firing the ball into the ballistic pendulum. So once we have all of this data, Hooke's law will be calculated for us immediately, and we already have our initial velocities here. They are coming directly from our calculations from the last experiment, and we have our compression lengths here. So I went on and took the compression lengths, or took measurements for the compression lengths using a micrometer, and we were coming out with 0.03473 meters. And this is good out to these 1, 2, 3, 4, 5 decimal places because I used a micrometer. Now the goal is to find the compression or the spring constant, but the spring constant for each one of these compression lengths. And we're trying to determine whether the spring constant will remain the same. Will it increase based on the click position increasing? So we have click position 1, click position 2, click position 3. Will the spring constant increase? Say yes or no. Okay, good. Will they stay the same? Say yes or no. Okay. So whichever one you choose, even if you think that they're going to decrease, whichever one you choose, just make a choice. And this is like forming a preliminary hypothesis, even a hypothesis, because we have some theory that we're basing it on. We have some evidence that we're basing it on. So we're not just willy-nilly in it at this point, if you understand what it means to willy-nilly. Okay. So let's go ahead and get that information, and I want to show you where that information is going to come from. So quickly, we will go to video physics, and in video physics, I'm going to show you the videos that we used. We used the first compression video, and we used this last time. So we have our data here. We should have already moved the data over. If I just play this, you'll see that hopefully this is familiar based on the last experiment. If I go back to experiments, you'll see that I have the second compression here as well. And so it's a similar kind of experiment. Just firing it. Okay. Excuse me. And then, of course, we have our third here. And we only had 4 shots on this one because the ball kept falling out. So in my mind, it's not doing what I want it to do, so I stopped. Okay, let me pause that. So we moved all of this data over to Microsoft Excel. And I want to show you where that data is located. If we go back to number 16, you'll see that we have our first compression, and I actually have duplicate copies here, but first compression, second compression, and third compression. If you look at the first compression, we should have already conditioned our data. Okay, it's the same data. And here it is. What I want you to do is I want you to duplicate this file. Okay, so duplicate it and move it into Hooke's law. Move it into Hooke's law. Okay, so I'm just going to cancel that because I already have it there. And I would like for you to do that for the second and the third as well. So now I'm just going to go to Hooke's law. I am going to open up my first compression data set. I'm going to select on C, and then I'm going to copy this information. We know that our data set is solid because we've already conditioned it from the last time. And we're just going to paste this into our first compression position here. So I'm going to select on C, and then I'm just going to paste. And all of our calculations should come out. You see we have 2.9 here. If I go down to Hooke's law, you should see 2.9 populate right here. And the spring constant populate as well. It's just the formula that's in there, and it's based on the theory. If you want to know more about the theory, either look at the videos in the experiment or in the knowledge base. If the videos in the experiment are gone, then look in the knowledge base. So now I'm going to go and acquire the data set for click position 2 and then 3. And go back. It won't go back for me, y'all. It won't go back. So I'm just going to close that down. I'm going to go back into Microsoft Excel. And it's bringing this down for me. So it takes us right back into the experiment. And notice that it did not save my information for the first compression. So I have to go back and get that. Hooke's law, first compression. I'm just going to go ahead and put on all 3 data sets now that you understand exactly what I'm doing. So I'm just going to copy this, go back to the template here. And then go to the first compression again and paste. Go back. Second compression. Acquire this information. Copy. Go back. Go to the second compression and just paste. All right, so you'll see that we have our 3.6 for our initial velocity. And before I start looking at the data even closer, I want to go ahead and get number 3, just like I said before. And we're just going to copy this and go back into our template. And then paste. So that's not totally right though. Look, oh, I did the wrong thing. Oh my goodness. Let me go back. I want to hit this back button. I pasted my information in the second compression, but it's the third compression. That's one of the failures of trying to go too fast or getting mechanical, because then you take the thought out of the process, which it's understandable, but in this case, we need to be able to fix what we're doing here. So now I have all of this information in here. I have 5.4. I'm just going to go down here. I mean, we could look at interpolation, but that's not the point of this particular assignment. The primary thing is to look at Hooke's law here. And so now we have all of our velocities, initial velocities here, okay? And we have our compression lengths, and we have our spring constants. So you'll see that our spring constant started off pretty stiff. It got a little weaker, and then it got stiff again, okay? So it didn't increase. It did decrease, and then it did increase again, but it did not stay the same. So whatever your hypothesis was, that was your hypothesis. At this point, you would just have to alter it. So now what's the point? Well, Hooke's law really works for displacements over small distances. Going from 3.5, what is this, a millimeter? No, centimeters to 4.7 centimeters, that's rather large for Hooke's law. We probably would want to look at 3.3 to 3.6 or even, excuse me, 0.034 to 0.04. That small of a displacement may work, but I've not experimentally verified it. We just would alter our hypothesis, and then we would do a new experiment, and we would see if we are correct. If we're not, if we don't have the evidence to support us, then we have to just form another one. We either reject our hypothesis or fail to reject it. So Kind of like that language. That's it for this experiment. Make sure that you um, uh, give me the link to this folder on the STEM Initiative site.